A very good morning to my dear learners. So today, this is the second lecture and in which I'll be talking about organization of data, which is a continuation of the previous lecture. And here I'll be giving you the hands-on practice on organization of data. So first we'll look into the overview, what this lecture will entail. So by the end of this particular session, you'll be understanding the whole concept of frequency distribution. And later, with the different steps and with the different, you can say, the background of frequency distribution, you will be also be able to explain what are the different types of frequency distribution. And lastly, but obvious objective of this session is that you will have a hands-on experience how you're supposed to organizing the data, right from creating tallies, from frequency tables, and we'll be handling with many different examples of discrete and continuous data. So let's get started. And just before I begin, and I would ask you that, especially when I'm doing the hands-on experience, I would like you to take time. You can also, if you're listening to the 2x speed, try to reduce the speed of the lecture. Listen to the steps. Take a pause. You can also pause the video and try doing working out the whole, the frequency distribution along with me. So at least our and my speed and your speed should coincide. So we'll be doing it together, and then we'll actually know, we'll get that hands-on experience as well. So first, there's a bit of a theory here because I have to start with some background. So of course, remember when I'm talking about data, we have been talking about data since the previous lectures. So data is a plural form, right? And the singular is datum. And if you look at the dictionary meaning of it, so datum is a fact. So therefore, in the plural form also, the word data signifies more than one fact. Okay. Now, in the broader sense, the term data denotes the evidence of facts describing a group or a situation. So if a teacher wants to record the height of the students, so that single measurement will be called as datum. For example, Ravi's height, okay, that is 150 centimeter. But however, if the teacher wants to collect the height of all the students in the class, so it could be Ravi, Shyam, Ahmed, so it would be 150 centimeter, 155 centimeter, 160 centimeter. All that collection of these facts will constitute the data. Okay. Now, in order to do so, when you're collecting the data, we need some suitable method. How can we collect the data? So the four simple methods are either you collect through the interview, we collect through the questionnaires and surveys, and I'm sure you are quite familiar with Google form being circulated on WhatsApp group to collect your opinion, your perception, your attitude. So these surveys are also being collected, these links are sent to collect the data from you regarding any particular variable. It could be also in the form of observation and the documents and records. So the data collected by the research from the first-hand sources using methods like survey and interviews, experiments, and so on, all that will constitute the primary data. So you can see the primary data. What could be the advantage of such a data? Of course, it will be reliable, it will be accurate, and of course, because you're collecting data in the real time, so it is best that you can easily generalize that particular the findings based on that particular primary data, right? But of course, there will be some limitation also that collecting data could take a very long time depending on the sample that you're collecting from, right? Just as we have primary data, we also have what is known as the secondary data. So secondary data will be the data gathered from studies, from surveys and experiments, or from any research papers that have been published or that have been run by other peoples or for other research, and you are quoting them in your research work, right? So those are the secondary data. Now, in secondary data, of course, we can say that the advantage of this particular secondary data would be that of course, it saves time, efforts, and expense as well, because you're not doing something right from the scratch. Okay, you're getting the ideas from the other surveys being done, other documents being published, and research papers being published. So it is time saving. Okay, but of course, with everything there's a limitation. The accuracy could not be known, or the data may be outdated, depends on when the data was being collected, and then it got published, and now you're using that particular information. So there is also a time lag here. So the large volume of data requires, of course, you have management, right? So data management refers to how you're collecting data, how you're storing data, organizing it. And then finally, you're displaying it to be analyzed for the efficient use of information. So you're treating it with appropriate statistical technique. So the raw data can be arranged in the following ways. Either you arrange it into the alphabetic order, you arrange it into the ascending order or descending order. And the arrangement or arranging the data in either ascending or descending order is called what we can call it as array. So the array data is much easier to understand and to interpret because everything is so organized. Even if it is in a sequence, in a chronological sequence, you're arranging the years in ascending order, descending order. So of course, the whole cumbersome, bulky data can be manageable, right? And it can you can make sense out of it. It can see it, the whole tabulated data will seem meaningful to you. Okay. So now the key word, like I use the word tabulate. Now, what is tabulation? So remember in the last lecture, I talked about what Blair said about tabulation. So tabulation, if you look into the broader sense, in the words of Blair, it is an orderly arrangement of data in columns and rows. So basically, it's in the form of a table. So tabulation, which is obviously the next step of classification, is designed to summarize lots of information in a very simple manner, right? So there will be rows and columns in which you'll be arranging data. Then if you remember, I talked about the objectives of tabulation. So tabulation helps in simplifying complex data, and the bulky data will be organized in a very simple manner. It facilitates comparison because it gives you a bird's eye view and you can easily compare column A with column B, the data that is being present. It facilitates presentation also when you're presenting your ideas. So easily you can present your ideas to the larger audience. And once it's there in the table form, then you can apply the any kind of a statistical treatment. So analysis can be done. And after analysis, it also helps in reference. How are you referencing and how are you basically inferencing the data after the analysis, and you're deriving some kind of a conclusion out of it. Okay. So till now, we have seen that all this constitute the background before I start on with the frequency distribution. Okay. So because with the frequency distribution, I will be obviously talking about first the theoretical aspect, and then of course, then we'll be having the hands-on experience regarding it. So frequency distribution. Now, the data has been arranged in the tabular form, which shows the frequency of each item. So that kind of a distribution, which shows the frequency of each item in a tabular arrangement, is what we know as the frequency distribution. Right? Now, according to Croxton and Coden, they have said that the frequency distribution is a statistical table in which different values of a variables are shown in sequence of magnitude along with corresponding frequency. So the magnitude is also arranged in sequence, and along with it, the corresponding frequencies are also there. So let's have a look at the first, you can say, frequency distribution, which is showing, which is of a discrete type. So a discrete frequency distribution deals with discrete variables. Discrete meaning specific, separate values, usually a whole number. So each observation is distinct and independent, from one another. There's no overlapping, and typically used for a countable thing that you can count, like the number of children, the number of books, the number of students. Okay. Now here's an example. There are 15 students who have borrowed books from the library, right? So, the number of books that have been borrowed by the 15 students, they are being given in this form. Now, this is your raw data. Now, this you have to arrange in a form of a discrete frequency distribution. So, the most common, you can say, the first step that we'll be indulging ourselves in would be how we are trying to create a tally chart. And mind you, this tally chart, it's not only when you're doing statistics that you will be applying this. We apply this tally chart even in our daily life. Sometimes we just have to count the number of students, or we have to count some number of items at our home. So it's so easy to make a tally chart, right? So what is this tally chart? So the number is each one observation, the number of observations are represented by a vertical line. Like this will be one observation, right? So we try to group the lines for easy counting, and that grouping will consist of 5 lines, maximum 5 lines. So either you can have one observations, 2, 3, 4, and the fifth. The fifth, in order to mark that the group is end, now this is the last observation, either the fifth will be placed diagonally. That is the most common way. But in some books, you must have also seen in this form. Also, it's placed in a horizontal manner. In both the manner, it is sufficing that there are 5 observations that are being counted for. Then the frequency column will give the total count for each category. So that's how you start making a tally chart. So what is the benefit of using tally? It is basically a very easy counting of any discrete data. You can try it at home. Any data that is very discrete in the form of whole numbers, very specific and separate values. So you can easily do that. Make a tally, you can easily count. It reduces errors when working, and it makes it so easy to create a frequency tables and graphs based on tally. So let's have a hands-on experience on making tally. Now you see, the very same example that I gave you, in which there will be number of books which are borrowed from a library, and this data is collected from 15 students. So you see, now you have to make the tally. Now look, you have 0. How many zeros do you have? We have 1, 2, 3. You can count like that, but if you go in the sequence, 0 is 1, right? Then 1, you have this one would be placed here, right? One observation, another one observation, 2, so that you follow the sequence, okay, so that you don't miss out any observation. Here we just have 15, so I counted 0, 0, 0 very easily. But what if there were 50 observations, 50 students, 75 students, 100 students? So you can imagine, you cannot just count like that, okay? So you have to go in that sequence. So 2 we have already placed here, another 2, you place it here, 3, you place it here, the tally, 1, yes, I've placed it here, 0 here, 2, another 2, 1, I place it, this is now, remember, now this is the fourth one, 3 is placed here, 2 is placed here, 4 has been completed, 1, now this one is the fifth observation. So what do? I put a cross around it, right? Then 0 will be here, 2, this is also the fifth, so I put a cross around it. So what do I get? I get 3. I count the observation 3, and you needn't count this. This is, this is a complete set of tally. So this is 5, this is 5, and this is 2. Now having written that, now you can note the total number of cases. The total number of cases, which is also denoted by n, will be the sigma, that is the summation of f, the frequency. So if you count this, 5 plus 5, 10, plus 3, 13, plus 2. So what do you get? 15, right? So this is the data collected from 15 students. So this is how you can also do it right now and calculate the tally. So with any discrete data that is available, you can do that. Okay. Now let's have a look at the second example, which is in the form of continuous frequency distributions. So a continuous frequency distribution is such a distribution in which the data are arranged in classes or groups, which are not exactly measurable. So here the class intervals are what? They're in a continuous form from the beginning of the frequency distribution till the end within a given range of data. So how can we create a continuous frequency distribution? Let's have a look. Now this is the data that is given. This is the data which is basically secured by 25 students in the arithmetic test of class 8. So what are the steps to be followed? Here are the steps. First, you determine the range. And I'll tell you in a little while. We'll be following step by step. So first, let me explain you what are the overall steps that you have to conduct in order to make a frequency table of a continuous type. Then you determine the size of the class interval. Third step would be when you start writing the content of the frequency distribution. Then you write the class interval, start putting tallies, counting the number of tallies and checking the total number of frequency. This is exactly what we did in the previous example. This is the step that we conduct when we have a continuous frequency, when we want to create a continuous frequency table. So how do we do that? First, we have to determine the range. Now, what is the range? So range is the gap between the highest score and the lowest score. So, and with the range, it gives you the idea how spread out your data is. So here we have the highest score as 50 and 10 as the lowest score. So your range would be highest minus lowest, that is 40. This is your range. Second is that you have to determine the size of the class interval. Suppose the number of class desired is 8. Classes that are desired is 8 and the range is 40. So what will be the formula that you will be following is when you want to know the size of the class interval, it will be range divided by number of classes that you desire. So if the range is 40, which is already being established, the classes that you desire, you want 8 classes to be there. So 40 divided by 8 would be 5, right? So far, first and second step you know. Now comes the part where you start writing the contents of frequency distribution. And the contents of the frequency distribution are written in 3 columns. So you make 3 columns. First column will be class interval, second would be the tallies, and then of course would be the frequency, right? So how would you write the class interval? So you know the lowest score of the series was what? 10. The sizes of the class interval we just established in the previous, and it came to be 40 divided by 8, that is 5. So the first interval would be 10 to 14. That is, the class interval between 10 to 14 is 5. So your next would be what? 15 to 19, right? 15, 16, 17, 18, 19, 5. Similarly, then after 19 it would be 20 to 24 and so on. So you start writing down the class intervals. When you know the lowest score, you know the class intervals, so you start writing the class intervals. Then here's the part where we have already done. So after writing the class intervals, what are we doing? We are looking at the values and we started putting the tallies. Once we hit the 4th tally and we want to put the 5th tally, then we put it in this form, right? So one set of 5 tallies is being recorded in the table. Then comes the totaling of the tallies, in which you start adding up the tallies. So number of tallies would be reflected in the frequency column, F column. Okay. So now let's draw a frequency distribution table. Now this is the example of we can say you can say of any kind of a data that is being presented here. You want to create a class interval, then the tallies, then the frequencies. Okay. Now, remember the steps that I've talked about, the lowest score, the class interval, and how we started with the first class interval that was 10 to 14. Either you arrange in descending order or you arrange in ascending order. That will depend on you. Now you take a pause, you can pause the video and now start working on your table. Start arranging first the class intervals, either in ascending, descending order. Start putting up the tallies just like I've showed you, and then you count the tallies in the frequency column. Now, once you do that, now I want you to see this table. Now, see how many of you have reached and have exactly the same table that I'm displaying. So you see, we started with 10 to 14 and we ended with 50 to 54. Now, what do we do? Once you do that, now the last step that is left is once the tallies have been created and the count is also being maintained, then you calculate summation F, the sum of this, which is also basically this is also the N, total number of cases. So we have 25 cases, right? So it's basically the summation of this. So this is how you create a frequency distribution. Now let's have another example for you to work on. And now this is another data that is being in front of you. It could be any data. It could be the scores or the number of goals or the number of runs made by any athletes and so on. Now, if I give you just a hint that construct a frequency table with the class interval 40 and 50. Now you know the range, you know the class interval, and start arranging. First, you diagnose the lowest score in this. What is the lowest score and the highest score? And then you start arranging your data. And that data, remember, the lowest is, you can already diagnose it's already 0. So you start arranging the data, and in the you can say after arranging the data, your whole class interval will start looking like this. We'll start from 0 to 10, 10 to 20, 20 to 30, and so on. And you will reach till the highest score, which was here 100 to 110. That's within that range, you will find the highest score which is present in this particular table. Then coming to tally mark. Now let's see how many of you got this tally mark correctly. Once looking at this, for example, 34, once you start from the beginning, once you have 34, then where will you mark it? You will mark it in this particular group and you will put a tally mark here, right? So likewise, start putting tick at this side, right? Then next you have 56, so 56 would be here. So once you do that, this is how your tally marks will start looking like. Then would be your frequency, and of course, then your summation would be here. Sigma F. That's how it would look like, okay? Now coming to the types of frequency distribution. So we have different types. So the first type is exclusive series. As the word suggests, exclusive. That is, something is being excluded out. Now, the series with the class interval in which all the items have been arranged from lower limit to the value and just below its lower limit are included, right? And the other is excluded. So in other words, or you can say in simpler words, I can say that it's a frequency distribution which can be labeled as exclusive series is when the frequency corresponding to a specific class interval do not include the value of its upper limit class, right? So from the above table, we can see the upper limit class interval will not be included in this particular count. So if, for example, if I ask you, if there is a value of 10, where will you place it? Will you place it here or will you place it here? If it is an exclusive series, that means you will exclude the upper limit. You won't place 10 there, but you will place 10 here, right? So it will be included in the class interval 10 to 20 and not in 0 to 10. This is known as exclusive series. The second is inclusive series. So here the values are included, unlike exclusive series in which it was excluded. So here the range from the lower limit to the upper limit are all included here. So if you have 10 to 19, of course, the 19 would be coming right in the 10 to 19, and right from 20, it will be from 20 to 29. This is, I think, fairly easy and fairly basic. You can understand where the value of 20 would be, where the value of 39 would be. But in the exclusive series, don't get confused. We don't place that particular value just because it is lying at the upper limit, like 10 was lying at the upper limit. We'll include it in the next class interval. Okay. Now, open-end series. Now, open-end series is where the lower limit of the first class interval and the upper limit of the first class interval is not available. Either you will write below 10 or you will write 30 and above. So, any cases that will be 13 above will be grouped in this particular category, and cases below 10 would be grouped under this. So, what are we doing? This is known as the open-end series. We're opening the prospects of the observations that can be included in it. Now comes cumulative frequency series. So a frequency, you can say a series which shows frequencies which are continuously added and corresponds to the class interval is known as cumulative frequency series. Now this is the mark, these are the marks, and these are the frequency. So how would you create a cumulative frequency out of it? So how would you do that? So first would be, the first cumulative frequency will be 0 plus 3. We have 3. Now this 3 will be added with 5 to give you 8, right? Now this 8 would be added again to 2 to give you 10. And 10 added with 8 would give you 18. 18 added with 9 would give you 27. So this value will be exactly the same as this value. Okay, so that's how you create a cumulative frequency series. Now comes a part where the mid-value frequency series, you have to record the mid-value frequency series. If the mid-values are given, how will you make the tabulate the data? So a series in which instead of class interval, there are no class interval here, remember, they're only mid-values. So this is known as the mid-value frequency series. So you have to convert the mid-value frequency into a simple frequency series. So how do you do that? This is the formula that you should know. So if you want, because definitely to create a simple frequency series, you need a lower limit, L1, and you need an upper limit, that is L2. So for lower limit and upper limit, the formula is fairly simple. It is m. For lower limit, you have m minus half of I. So m is the mid value and I would be the difference between mid values. Okay. Similarly, for upper limit, the same thing, but here we have with the addition sign. It is m plus half of the difference between the mid values. So having said that, now let's first work out on a problem. Now let's look at the example how to calculate a frequency class interval from the mid values, right? Now this is the mid value that was given to you along with frequency. This was the question that was given to you. Now what was the formula? Now this formula is already being pasted here, so you would understand this. And let's work it out. Now let's simultaneously work out this problem together. So first we'll establish the first step would be determining the mutual difference between the mid values. So that amount to 10. So you can see the difference. 20 minus 10 would be 10, 30 minus 20 would be 10, 40 minus 30 would again be 10, and then 50 minus 40 will be 10, right? So this is the difference that we are seeing in all the mid values, right? So now we know what I is. Now let's create a table together in which we'll be creating the lower limit as well as the upper limit. Now this is how your table should look like. Now let's see if you're able to calculate it. Now let me divide it into 2. Now this is the part of L1 and this is the lower limit and this is the upper limit. Now when we are calculating it, L1, so the M is the mid value. Now mid value will be corresponding, which is already mentioned in the table. So here M is 10, so definitely this is M in your formula, right? And it's already present in the table. Here is 30, 40 and 50. And remember, this is half of the difference, that is 1 by 2 into I. So that is 10 by 2, which is 5. Okay, now we have established that. So 5. So whatever mid value is there, you have to subtract 5 from it, right? Similarly, with L2, that is your upper limit, what are you doing? You're adding here. So the mid value, adding with the half of I, half of your mid value, that is you are plusing, you're adding 5 to it. So you will get the upper limit. So once you have calculated L1 and L2, now let's make the class interval. So it is 5, 15, then 15 to 25, 25 to 35, 35 to 45, and the last value which I have left out was of 45 to 55, which was for you to calculate 45 to 55, right? So once you have done that, now let's see how many of you have got the table correctly. So you place the class interval next to the frequency table, the frequency column. So first you'll have the mid value, then the frequency column, and lastly the class interval. So this will corresponding exactly with how you calculated, right? So that's how you basically calculate the class interval if the mid values are given with this particular formula, that is m minus half of I, that is difference between mid values, and for upper limit you're calculating in the form of L2, that is m plus half of the difference between mid values. Okay. The next is the univariate distribution. When we study one variable, and it's just a frequency distribution, it is known as the univariate distribution. So it focuses on a single characteristics, right? So you have the marks range here and you have the frequency, okay, which is obtained. So here is a single characteristic. That means you are looking into the marks of the 15 students. So this is how you arrange the tabulated data and of course the range of it. So this kind of a thing, this kind of a table is known as univariate distribution. Second is the bivariate distribution. Bivariate meaning two variables are simultaneously studied and the relationship is looked into. That is known as bivariate distribution. So it helps us to see how one variable can change with respect to another. So here we have students along with the marks and along with study hours per day, right? So marks, they are dependent, their response variables, and study hours per day could be an independent variable, exploratory variable. So this basically the table shows how marks vary with study hours, right? Making it a bivariate distribution. So to conclude, what can we say? Understanding frequency distribution enables us to organize and interpret data more effectively. So by learning its type and practicing the creation of tallies and frequency tables for both discrete and continuous data, what are we doing? We are gaining the ability, we are identifying the patterns, we are identifying the trends and the variation within the data set. Now this foundational skill, it not only simplifies complex information, but it also strengthens our analytical skills or an analytical thinking as well. And that is an essential step towards meaningful statistical interpretation. Okay. So here are the list of references and the web links that you can go through for more comprehensive reading and do a lot of practice on tally and on frequency distribution and so on, right? So, and other than that, I would also like to advise you that in statistics, the more you practice, the more the hand-on experience that you will get. Okay. So thank you all for your patience listening, and I'll be seeing you again in the another lecture in which we'll be having hands-on experience yet with another statistical variable and another statistical method. So till then, take care of yourself and have a good day. Thank you.